Hey there, everybody, welcome back. We're gonna start in on chapter 6. On Thursday, we'll do a group practice test. You can take the practice test right now yourself, it's available on campus, I'll show it to you guys at break time. But like the practice test isn't worth points, it's more of an opportunity to see what the test is, it looks approximately like. And like if you work with others, you can find out other tips and techniques that people use to learn the shit, know the shit, and you might find it useful. I tried this for the first time last semester, and the students that came and participated resoundingly said, yes, keep doing this. So we'll see how it goes. That's Thursday. Our test is next Tuesday. So for today, we gotta do something. We're gonna start chapter 6. I figured I could have given you the review today and done the test on Thursday, but where's the fun of that? This gives you an extra weekend study. That's probably a good thing. Chapter 6 is on circular functions. And their graphs. 6.1 is on something called the Radian measure. Radians are interesting. Students resoundingly hate them. I've used the word resoundingly twice now in like 2 minutes. Resoundingly hate them when they first learn them because it's something new that you're like, why the fuck am I learning this? And yet later on, when you're in calculus, you're like, this shit's so much easier once you've learned it. So, but to motivate it, let's go with circle. That's not a great circle, but that's not my worst circle. Let's give it a radius r. Does anyone know the formula for circumference? Another word for circumference is perimeter. In fact, it's the only shape that uses circumference rather than perimeter for some dumb ass reason. Probably some Greek or Latin fuck came up with this. Anyone know the formula or remember it? It's 2 times pi times the radius. So pi, this is actually a Greek letter. But it is so important to circles that we assigned it to a number. And the number is approximately 3.1415 to 4 decimal places. It is an unending number. So it's a decimal that keeps going on forever. It doesn't repeat. And on March 14th, all across the country, there are fucking nerds that get together and do pi recitals. Like I've been to a math event on, it's called Pi Day because it's March 14th, 3.14. And I've watched people do it. I know this isn't my thing, but I've watched people do it and like recite like 100 decimal places, 200 decimal places, pi. Not crazy. Most calculators have this on there. Do not use approximation if you have a calculator. If you have a calculator, anything like mine, mine shows up here. It's usually one of the functions that you have to use, like the shift key or an alternate key, second key. If you don't know where it is on your calculator, show me your calculator break or after class, and I'll show you where it is. So you should use it. So the circumference is 2 pi r. So like if r is 1. Then the circumference is 2 times pi times 1, which is 2 pi. which is approximately 6.28. In fact, this formula is worth remembering if you don't know it. You should memorize that one. It'll do you good to memorize pi to a couple decimal places, but if you do more than 4, just it's because you enjoy it. So circumference is going all the way around the circle. It's like if I started here and I went all the way around, the distance around is the circumference. What if I went around a half circle? Only halfway. I start here and I went around following the green line and I stopped here. Half a circle. What would at this point, it's not called circumference. At this point, this is called like the distance for an incomplete circle. Or partial circle. We call that arc length. With a C, not a K. K is the one that pulls animals. Meant for floods. The boat arc. And we tend to give the letter arc length a letter, we give it S. I don't know, there's no S in it. Maybe because the S looks like a curvy thing and you're like, I wonder how long that is. I don't know. No idea why they give it an S. But what would the S be for a half a circle?
Would it be the same formula divided by 2?
Yeah. Well, we're saying S is 1/2 the full circle. So we say 1/2 times 2 pi r. And the 1/2 and the 2 cancel out and we're left with pi r. Here's a reason why I'm going through all this. There's a method to my madness. This is my brilliance coming out. I've never taught it this way, I'm doing it this way. Hopefully you'll appreciate radians more. How many degrees is that? How many degrees is a half a circle? Someone was quick with that. It is indeed 180 degrees. I need time to write that down before we switch the page and we unleash the magic that just goes, makes you just head yourself. Boom! Like, whoa, that's some deep shit. Anybody in this page up longer? Anyone's, I see a couple things still gone. I can get you to appreciate why we use radians. It's gonna be so much easier for you to be interested in learning radians rather than going, I don't fucking need this. I don't get why we're doing it. So like the why is pretty fucking important. So I have that radius again, R. And I'm gonna do a dotted circle going around it. That way, when I show the arc length portion that I'm gonna show. It's a little bit easier to see, and I'm like, Jesus, this circle is not getting any better. Drawing a circle by hand is pretty hard. If you listen to Gerardo talk though, that's how you draw straight lines really hard too. What if I have an arc length that's about this long, where S actually equals R? It's the same length as the radius. Arc length equals radius. Now, you guys were able to tell me, I know you know what a full circle is, and I know you know what a half circle was. Can you tell me how many degrees that is?
It's not 90 degrees.
It looks like it's pretty close to 60 degrees. It's something god awful miserable. I don't know what it is. I bet we could calculate it. In fact, we'll calculate it in a little bit. So what they did is, this is where the math said, you know what? Let's just let's come up with a new angle measure. Let's call this angle measure theta here. We're gonna do an angle in radians. Then we'll say when arc length equals radius, theta equals what? 1 radian. Look what happens if I divide this, S equals R, if I divide both sides by R. I get S over R equals 1. And we just said theta equals 1. So I can say S over R equals theta. And if I clear the fraction, multiply by R again. I get S equals R theta. This is the formula for arc length. When theta is in radians. Something else kind of interesting about the radians. Theta equals S over R. Let's say R was 2 centimeters. And for 1 radian, when theta equals 1, S equals R. So S equals 2 centimeters also. Then we have theta equals 2 centimeters over 2 centimeters. Doing S over R. Not only do the 2's cancel out, but the units cancel out as well. Radians are unitless. They're not units. Degrees have a unit, it's the little degree symbol. Well, and the word degrees. In fact, after a lecture or two, I'm gonna stop writing the word radians when I talk about the number. I will say like this many and I'll write radians for a while, just to make sure it's clear everyone's on the same page. Eventually, you're just gonna know that we're talking about calculator, we're talking about trigonometry and we're talking about an angle. If it's not in degrees, it's in radians. Since degrees and radians are two, they both measure angle, but they have different values, your calculator has different ways of going about doing it. My calculator right up here has a little D. Your calculator might say D as well. I have a button that says mode. Says mode right above it. I don't know if you can see it very well. Just maybe you'll see mode. If I hit mode. And I believe it's 2. Nope, that wasn't it. Oh, I gotta hit mode again. My calculator's hit mode again. Every calculator is different. If you can't figure out how to get between degrees and radians, I can help you find out. When I hit mode twice on mine's at Casio, a lot of the basic scientific calculators, the cheaper ones do something similar. I have the option of doing it when I hit 2 here. Now it doesn't say D, it says a little R. So let me go back to radians or degrees for a second. Remember when we did like sine of 30? Does anyone remember what the value of sine of 30 degrees was? It's just something to memorize. It's 1/2. So if I put this in radians. And I say sine of 30 degrees. That ain't right. Why is it saying negative? I got fucking SD mode on still, I don't know what the hell that does. You know what, turn it off, turn it back on. That didn't fix it. Regular. Nope, regular. Oh. There we go. Am I in degrees still? Nope, I'm in radians, okay. Sine of 30. Huh. I don't know why it's giving me a negative radian.
I was doing the same for me.
Yeah, it should be a positive amount. Oh, I know what it's doing, it's giving me the Y value. So. Let's talk about the difference between 30 degrees and 30 radians. Yeah, brain farted. .30 degrees is going approximately that amount, right? It's probably not perfect, but it's pretty close. One circle. One full circle. S equals 2 pi r, the arc length. If we say r equals 1 here, we see that s, a full circle is 2 pi, which is about 6.28. Which means 30 radians. Well, 4 times 6.28 is, what is 4 times? Actually, more of looking at 8 times pi. It's about 25. 5 full circles. 5 times 2 times pi is 31.4. So 30 radians is going around once, twice, 3 times, 4 times, and almost a 5th time. That's 30 radians. They are different. It's very important that you know that they're different. So when I did sine of 30. And it's in radian mode. It's showing me that sine, and remember sine is y. That's almost directly straight down. Which would be y equals -1. It said -9 point. Or -0.98 or something like that. Second to process that. Look at a unit circle. This is called the unit circle. Whenever you see the word unit. Unit something in math. Means something with. Something has a length of 1. For a unit circle, R has a length of 1. So let's take a look, in fact, I even said it earlier. If S equals R theta. And we do a full circle. Remember, S is the perimeter, the area around it. For a full circle, S is 2 pi R. And if I divide both sides by R. I see that for a full circle. Theta is 2 pi radians. Because the R's cancel out. And we're left with theta equals 2 pi. That's true for any radius circle. Interestingly enough. What's the full circle in degrees?
60.
It's 360 degrees. So this is where we get to our conversion. Both of these are theta, and we know it's for the same amount, same angle, we're talking about a full circle, which means for a full circle, these are equal. 360 degrees must equal 2 pi radians. A half circle, so that's full circle. Half circle is how much in degrees? Is 180, and we did that by dividing by 2, right? We divide by 2 on the right side, we just get pi radians. So this is the one that is easiest to build off of to get your conversion between radians to degrees, in degrees to radians. If I want to go from degrees to radians. Well. I start off with 180 degrees. Equals 2 pi radians. And to get a nice conversion, it's helpful to know what 1 degree is. So if I divide both sides by 180. Wait, that's not 2 pi, that's just single pi. If I divide both sides by 180. I get 1 degree equals pi over 180 radians. So like, let's say I wanted, I don't know. Someone pick a nice degree amount for me. It doesn't need to be friendly. Pick a number.
1, 2, 3.
1, 2, 3. If I wanted 123 degrees in radians. That's just like multiplying this. By 123. Right? If I multiply the left side, I get 123 and we got the degrees. So 123 degrees is gonna equal 123 times pi over 180 radians. Which is approximately 2.147. If I want to go from radians to degrees. Well, we start off with that same 180 degrees equals pi over radians. And if I divide both sides by pi. I get 180 degrees over pi equals 1 radian. One radian this is the question we asked earlier. 1 radian was when the arc length equaled s. So we can actually find out what it is in degrees. 180 divided by pi, oops, that's not pi. 180 divided by pi is pretty close to 60 degrees. Turns out it's about 57.3. Any questions so far? Well, let's give you guys a you try. Convert. Let's say. 240 degrees to radians. And try converting 11 pi over 12 radians to degrees. Do it together in like a minute or so. I'll write down nice little recap here. Degrees to radians. Multiply. By pi over 100 radians. Radians to degrees. Pi by 180 over pi. Alright, so if I add 240 degrees. And I multiply by pi over 180. Who immediately went straight to the calculator and got some shitty ass answer? I bet most people did. Before I do that. Well, these are both multiples of 10, right? So this is kind of like. If I divided top and bottom by 10, I'd have 24 pi over 18.
You can still simplify.
I can still simplify more, can't I? They're both divisible by 6, right? If I simplify more, I get 4 pi over 3. That seems like a pretty easy answer to write down, and like, okay, I don't know how many degrees it is, but you're never gonna know the radians until you get really familiar with it. But you go to the full. Actual value, the full actual value. Oh, actually, no, this is the approximate value. No matter how far I go on this calculator. Well, that looks funny. Even if I went to 4 decimal places, I'm rounding. 4 pi/3 is exact. That is rounded. Avoid rounded shit as often as possible, which is convenient because the numbers are easier to do. You just have to simplify the fractions. And there will be some common ones we're gonna go over right now that you'll get used to how they simplify. If I wanna do the other one, 11 pi/12 radians to degrees, I'm gonna take 11 pi/12. And I'm gonna multiply it by 180/pi. Pi cancels. And I'm pretty sure 180 is evenly divisible by 12. 180 is 12 times 15. I just divided 180 by 12 to find out. So the 12s cancel. And we're in degrees. This is 11 times 15 is 165 degrees. Now, if you did it in the calculator, you should still have 165. If the coolness of 1 radian being the exact angle that the arc length equals the radius isn't cool enough for you. There's another good reason to learn radians. And I'm gonna say. Maybe even better. To learn radians. This is some calculus shit. You're not expected to memorize this right now, but you will when you take calculus. In calculus. If f of x equals sine x. Then f with an apostrophe. This is called the first derivative. Of f of x. Call it f prime. In degree mode. It's pi/180 cosine x. That's fucking shitty. That's in degrees. In radians. F prime of x is just cosine x. You don't need to remember any fucking fancy conversion, it's just sine goes to cosine. And when you do cosine, cosine goes to sine, a negative sign, but. As long as you're in radians, it works well. It's gonna make calculus easier. About, I don't know, a third of calculus. Easier. Like trigonometry comes up quite a bit. So like if we had to do that pi over 180 shit, fuck. Fuck all that. Did these. These were pretty important. I asked you to memorize like the sine and cosine, right? What are these in radians? Remember, degrees to radians was multiplied by pi over 180. So 0 times pi over 180 equals 0. 0 radians. Now, something that might help you for the next step. For the rest, 180 is 30 times 6. It is 45 times 4. And it is 60 times 3. So when I do 30 degrees times pi over 180, I'm gonna write the 180 that has 30 over 30 times 6. Yeah, I'll do a dot. That's better. 30 degrees cancel, and I'm left with pi over 6. A nice simple number. Ugly in the calculator when you turn it to a decimal, but not too bad to remember here. We do 45 degrees. That would, 180 was 45 times 4 there. 45s cancel, and we're left with pi over 4. $60 degrees times pi over 60 times 3. The 60s cancel. And I get pi over 3. If I do 90 degrees. Well, 180 is the same as 90 times 2, right? 90s cancel, and I get pi over 2 radians. They are all pi over an integer, a low integer, a low whole number. Let's take a 10-minute break now, because I want to show you guys a video that's about 15 minutes. That'll really help you memorize some of this shit pretty well. She does it way better than I do, she's really animated about it. Let's take a break now. Alright, so test I was telling you about. You can take a look at it here. I recommend giving it a try before Thursday, because I'm gonna bring about 20 copies. Try to force you guys into groups, because some of you are gonna be like, I don't wanna work with others. But that defeats the whole purpose of doing this fucking thing. Working with others will make you better, even if you don't need any help and you're actually explaining shit to other people. You get better at it and it becomes easier for you. It's a win-win for everybody involved. So, but it's worth giving it a try solo before you get to it. I wanted to show you this. If you look up Calc Workshop left hand, you might be able to find it, or left hand trick. Will I do it? She used to offer some of her videos for free, and this was one of them. She might have stopped. But if you look up creating the Union Circle left-hand track. Let's just give this guy a try, cause it's a really neat. Bitch, please. he's not getting to what I wanted to show you. So I'm gonna show it to you myself. Let's see, that would be the 45-degree mark. I guess 30 is a little bit closer there. So get rid of that. That's about 30 degrees. And 60 degrees is right about there. Maybe a little. And probably hit the power button, give me a second. You know what? Start with a fresh sheet. That was smart about it. My shit looked bad. Sit back out. So 45 degrees is exactly down halfway. And if I were to go split it into 3, that's about 3. So 60 degrees is right about there. 30 degrees is right about there. Of course, we have 0 degrees and 90 degrees. The left hand rule. Put your left hand facing you on it. Now, if you do it good, it like. Maybe you're making it bigger. I didn't make it big enough. Your fingers kind of line up with it. Okay, the top one is. So we start at 1 up here, like your thumb is 1, add 1 to it, this is pi over 2. This is your second finger, pi over 3, we'll add 1 to it. Pi over 4. 5 just skipped, unfortunately, that doesn't work for the 5. That's pi over 6. And this is still 0. Okay. We had for values here, this was 1, 0. This was sine was 1/2, cosine was √3 over 2. 45 degrees, we had √2 over 2 for both of them. 60 degrees, we had 1/2 and √3 over 2. And 90 degrees was 0 and 1. How do you remember these quickly? Whatever angle you're looking at, if you line them up kind of along lines. Let's say I'm looking at 60 degrees, I'm gonna bend my 60-degree finger back. I've got 1 to the left of it. I've got 3 to the right. 3 fingers to the right, 1 to the left. I've got 1 and 3 on top. If I look at the 30 degrees and I bend the 30-degree finger back. I've got 3 fingers to the left of the bent back finger, 1 finger to the right, and I've got square root of 3 and square root of 1. For the top. If I bend back the middle finger, which is awkward, I have 2 fingers to the left, 2 fingers to the right, and I've got √2 and √2 on top. So like if you put your hand over it and you bend back the finger that like lines up with the degree you're looking at. You can count your fingers and go, that's what the numerator is, with a square root. It's a fairly simple way of remembering the first quadrant. It works with degrees, it works with radians as well. Your first test is gonna give you, I'll show you right now real quick. Can you actually show the left-hand rule, jackass? In chapter 6, your first test, you're gonna have 2 parts to the test. In fact, you can see it when you look at the group practice test, I'm pretty sure it's on there. The first half, I'm gonna give you this, and you do not have a calculator, can't use a calculator in the first half. The first half is filling this in. That's for chapter 6, not chapter 5, that's not the test coming up, you got some time. Okay? But let's walk through how to do it. Go back to share. So I've got some other marks here. Let's fill in the, like the rest of the diagonals. I'll do the diagonals as dashed. So seeing spotting the 45 degrees is easy. And then for the other ones, you kind of just draw, like once you've got the first quadrant in, you draw a straight line through. And you just gotta pick one through the other one. So we knew in degrees, this was 0 degrees, 30 degrees. 45 degrees is the diagonal, 60 degrees is there. 90 degrees is here. We knew this is 180 degrees, you were all good with that. This is 270 degrees, and when we get back around to here, it's 360 degrees. Right? Using the reference angle idea works pretty well. If this is 30 degrees, then this is going back 30 degrees. 180 minus 30 is 150 degrees. This ends up being 135 degrees and 120. And you can either treat it as multiple, adding 30, 45, and 60 to the previous value, which works. 90 plus 30 is 120, 90 plus 45 is 135, 90 plus 60 is 150. If I do adding 30, 45, and 60 to 180, 180 plus 30 is 210. 180 plus 45 is 225. And 180 plus 60 is 240. If I do that with the 270 and add 30 degrees, I got 300 degrees. If I add 45 degrees to 270, I have 315. And if I add 60 degrees, I have 330 degrees. So the degree part was that. My radians all circle so they kind of stand out a little bit, because that's the new shit. So remember how we said all strippers take cash? We're gonna take advantage of this. S is like the first letter of subtraction. That's an easy way to remember what goes on here. Use the same denominator as the other side. This has a pi over 3, the 120 go directly over. This will have a pi over 3, and we subtract 1 from the denominator. 3 minus 1, I'm gonna put a 2 right here. 120 degrees is 2 pi over 3. If I do this with pi over 4, I put the pi over 4 over here, that's on like flipping it across the axis. 4 minus 1 is 3. I put the 3 on top, I've got 3 pi over 4. This is a way to quickly go through the radians. If I do the same here, pi over 6. 6 minus 1 equals 5. I put the 5 on top, I've got 5 pi over 6. So if you remember these first 5 values, and 0 is simple, there's no part to it that you need. If you remember these four, we can get the rest straight from just doing some basic operations. The subtraction's pretty easy to get the numerator there. To get the third quadrant. Treat the t like extend it a little bit, make it look like a lowercase t, yeah. You take the denominator and subtract 1. Bottom minus 1 equals top for the s quadrant. If I use a lowercase t for the take and all strippers take cash, lowercase t looks like a plus sign. Plus sign represents addition. So it's gonna be bottom plus 1 equals top. Just like I bounced over the y-axis to get these denominators here, I'm gonna bounce over the x-axis to get these denominators here. So I'm gonna have pi over 6 as the denominator here. I will have pi over 4 as the denominator there. And if I reflect that over, I've got pi over 3 here. In each of these, I'm gonna take the bottom and add 1 to it and put that on top. So 210 is 7 pi over 6. 4 plus 1, 225 is 4 plus 1 is 5. 225 is 5 pi over 4. This one, 3 plus 1 is 4. Put the 4 on top, 4 pi over 3. And we just did 240 equals 4 pi over 3, like a half hour ago. I didn't do the 180. I'll do the x-axis and y-axis last. That's kind of the easiest thing to do. This method works down here. If I put pi over 2 here, I add 1 to the bottom, I get 3 pi over 2. Just doesn't work at 180. 180 is pi. Fourth quadrant is not the one that has a nice little thing that goes with it. The one video I saw, she's like, use primes. I'm like, who the fuck's gonna remember the primes? So for this one, 2 times the bottom minus 1. So double it and subtract 1. And in this quadrant, it doesn't matter if you go across the x-axis or across the y-axis. This is gonna have like a denominator of 6 right there. That has a denominator of 4, and this has a denominator of 3. So if I do 2 times 3 plus or minus 1, 6 minus 1 is 5. The 300 degrees is 5 pi over 3. I do the same here, take the bottom, I multiply it by 2 and subtract 1. 8 minus 1 is 7, the top is 7 here. And if I do that here, 6 times 2 is 12, minus 1 is 11. 11 pi over 6 is right there. So bottom -1, bottom +1. And then 2 times the bottom -1. Believe it or not, you can get this down to like filling this, like the picture out in like 5 minutes. It's flashcarding and stuff. His whole thing of like, don't do. Using reference angles works and stuff, but if you have the basic ones memorized, it is faster when you're doing it. And on a test, speed matters, right? It's not just gonna be in this class, calculus is gonna have all your, any math class or engineering class or physics class after this. Will have trigonometry in it, if it's a basic angle, being able to come up with it like that because you have it memorized is in your best interest, that's why I make it part of the next test. Filling in the sines and cosines, I showed the finger thing for this one. Over here, again, it just reflects across, but over here, x is negative. Down here, y was negative. And down here, x is negative and y is negative. So we're just gonna take the numbers, reflect them over. And just change either the x value or y value. Remember, those numbers are written as x comma y. So whether it's positive or negative, we're gonna use the same values and just treat it that way. So if I reflect this one over, I've got 1/2 and square root of 3/2 right here. And x is negative here, so I'm gonna slap on a negative sign for the x. If I do this one here, this one was, the diagonal was the √2's. So this one is √2. Both of them, the denominator is always 2, and the x value is negative here. So we're gonna go negative there. And finally, this one was √3/2 and 1/2. And we give the x value negative there. =180 is -1, 0. The axes are, you should be able to do without everything else, because it's on the axes, you know what the values are. One of them is 0, the other one is 1, or -1. Now, we can go through and keep doing that symmetry thing, but I'm gonna show you the way I do it. Easiest way for me to remember it when I'm filling it in. And I'm not gonna have the radians and degrees stuff on there, I'm just filling in the x and y values right now. Put that on there, that way I can recognize the axes right away. Quicker way to fill this in. Is remember, everything has a denominator of 2. Going all the way around. Hopefully, that's easy to remember. The vertical and horizontal are a little bit different. But I'm gonna just fill in this part right here with the over 2 right now, make it simple. And I'll show you how I fill in the top. For the Y value. I count going up. 1, 2, 3. 1, 2, 3. That's exactly what it's gonna be on the same, on this side over here. 1, 2, 3. 1, 2, 3. If I go downward, 1, 2, 3. 1, 2, 3. Pretty straightforward, right? 1, 2, 3. I think we can manage 1, 2, 3. You have two ways of memorizing the other ones. I think maybe the easiest one is that cosine goes backwards. 3, 2, 1. And we're gonna do that same thing backwards, 3, 2, 1 on both sides. Oh, let me put it on the left. 3, 2, 1. Counting backwards, the little tick marks. Going this way, 3, 2, 1. And going back this way, 3, 2, 1. Now just throw square root over all those motherfuckers. And I'm putting the square root over all of them, but you're gonna look silly if you leave the square root of 1 as square root of 1. Cause it looks like you don't know what the square root of 1 is. But you're effectively putting square roots over everything. So if you can count to 1, 2, 3, and remember you divide by 2, slap a square root sign on. This thing is really easy to remember, like filling it out. You're better memorizing what degrees go with what radians. And what the sine and cosine values are there. But with practice. With practice and using reference angles. As long as you memorize this upper right quadrant. And you do the flipping and sign changes and shit like that. This is like memorizing, this is all you really need to do. And you can quickly get the other values. I would start there and then build the rest. Then on the. I kind of like the whole left-hand thing where you like pull the finger back. At least for the first quadrant, and it tells you what the left and the right numbers are on top. That's pretty handy. But when I didn't know that when I was first learning this shit. I had to learn it the hard way. And I didn't have someone giving me this kind of shit. It was just like, here's the fucking unit circle, memorize it. This is a pretty straightforward path, right? I eventually like came up with my own strategy for like, how am I gonna fill this out quickly? And I recognized this is 1, 2, 3, 1, 2, 3, 1, 2, 3 kind of thing. The alternative to saying 3, 2, 1 is saying 1, 2, 3 from the y-axis. But I think it's easier doing 1, 2, 3 and then just the x value is the opposite order, 3, 2, 1. I think that's the easier way to go. And then you're always working off of the x-axis, just like you do with reference angles. Reference angles are off the x-axis. So it's kind of an easy pattern to get into. I will try to have some blank worksheets printed out for next week. For you guys to have to practice on. But. As I was saying, if you come here. I'll show you all of these things real quick. Chapter 6. The blank unit circle is what you're gonna be able to need to fill in. I'll actually show that there. It should be on the test. Notice the first page of the practice exam. You're gonna get it as two different parts. They're not gonna be connected. It's fill in this circle. Zoom out. You have a blank circle and just to fill it in kind of thing. That is right here, right there. So if you want to practice without before I give any handouts. There's some interesting PDFs if you'd like to look at how they went about doing it. Like I said, that lady said prime numbers. If you look at what we had 5, 7, and 11. I'll show it in a second. Oh, there they are right there. 5, 7, and 11, those are all prime numbers. How is that fucking helpful? I don't know. I think because there's more prime numbers in that range too. I think doing double the denominator -1 is an easy way to remember it. And then the other one was. I memorized the unit circle. She's got the left hand thing. And she describes doing the finger thing. Shows a little picture of it. So if you don't remember it, like these are like handouts from it, and they are right there. So like you can always just look at it and go, how the hell did we do that? What else we got in this section? The biggest part of this section is. Actually learning those radians. There's a few word problems here using arc length. But 6.2 is really short. It's just 6.2 is almost all word problems. With just a couple of physics ideas. So I think I'm actually gonna stop here. Because like the next problems are word problems, it's kind of, those are more easy if you try to have at least tried filling out that circle and learning some of them before Thursday. It'll be in your bed, like doing it will work. We'll finish up 6.1 on. Shit, next week. Next Thursday. This Thursday. We're doing the group review, please show up, you'll get something out of it. Next Tuesday is the test. I will get here at 2:30, whether or not the previous teacher's out of the room at that time.
Often what three?
It ends at 3, but sometimes it's like today he was out at 2:30. So like I will be here at 2:30, if he's out by then. You can come in and start, and that'll give you an extra half hour. If you do have access and ability center, like do the testing in the testing center. And you brought me the paperwork, please email me as a reminder so that I can remember to forward the test sheet over to the AAC for your testing. Okay,
You're saying you're gonna give us extra time for that, or?
if I can. I have a class right after this one, so I can't give extra time after. And there's a class in here before it, but if they get out here early, as soon as they're out of here, I'll be in here and any extra time you get is. If you're here, that's next Tuesday, come for the practice on Thursday. And try to take the practice test, see what you know before you get here on Thursday.